And they say, well, what's new? What did you find out that we didn't know before? And of course, the big answers are the first galaxies grew differently than we expected, and we don't know why they're.
Yeah, and I think more likely our story of how the stars grow is wrong.
The ongoing discoveries made by the Webb Telescope are profoundly influencing how we comprehend the universe. As the telescope gazes into the distant past, it unveils mysteries that were previously beyond our perception. But wait, a surprising new discovery just shattered our fundamental understanding about the universe and reveals that we may be completely wrong about the size of the universe. In a new paper published recently, scientists have revealed that new images from the Webb Telescope have discovered objects just 120 million years after the Big Bang. Not only this, what scientists found in the deep early universe could break the entire foundation of the standard cosmological model. Astronomers say that we did not expect to see something like this in the Webb image, that the universe is actually very old, but not infinitely old. So that was a big surprise too. Einstein thought, of course, the universe must have an infinite age without a starting point. Well, he was wrong. So our intuition has just been wrong almost all the time. We're pretty confident that we don't know what we're going to find. Consider this. When the Webb Telescope looks as far into space as possible, it will only see about 46.5 billion light-years away. This is the radius of our visible universe, which we call the Hubble radius or Hubble sphere. By the way, the most distant galaxies discovered by the James Webb Telescope also fall under the Hubble sphere region. The most distant galaxy ever discovered by the Webb Telescope, the Mazies galaxy, which existed just 450 million years after the Big Bang, also exists inside the Hubble sphere. But we know that our universe is expanding, and as the universe expands, this Hubble region is becoming larger and larger, making it possible for objects beyond this Hubble region to be visible. But here's where it gets really intriguing. The universe isn't just expanding, it's accelerating in its expansion. Beyond the edge of the Hubble sphere, the expansion is happening faster than the speed of light. And because of this, the size of the Hubble region will not increase forever. When we look at extremely distant objects beyond this Hubble boundary, their light is trying to reach us. However, due to the accelerating expansion, the space between us and these far-off objects is stretching so rapidly that the light emitted by them cannot keep up. This means that the light from those distant stars and galaxies is effectively moving away from us faster than it can reach us. This means that the Hubble sphere will stop growing once it reaches the cosmic horizon limit, a region called the observable universe. This observable universe is a 93 billion light-year wide imaginary spherical shell around us. This is the maximum distance up to which we can see galaxies or stars. The light coming from inside this sphere must have been emitting light for a long time, so that light could reach us. Anything outside of this sphere will not be visible to us ever. Even with the strongest theoretical telescopes, we cannot see that far because the light from there just isn't here yet. That does raise the question. Just how big is the entire universe outside the walls of our observable universe shell? Well, we don't know. But we have estimated, or rather, the maths in some of our current cosmological theories suggest competing answers to this question. Although we do not have enough information to come to any certainties yet, and may never. For all we know, it could be infinite. But some research has indicated that our full universe is at least 250 times larger than our observable universe. There are estimates of our universe being 10 to the power of 122 times larger than the observable universe. This represents an astronomically huge number with an incredible number of digits. But the uniform distribution of matter in the universe and the isotropic distribution of temperature in the cosmic microwave background radiation suggest that our universe may be infinite in size. Now, here's the interesting thing. When we look very far into space, we actually see backward in time. The most distant galaxies we see near the Hubble sphere are not galaxies that exist now. They are galaxies that existed billions of years ago. We are just looking at the past of the universe. According to our standard cosmological model, which says that about 14 billion years ago, the entire observable universe and everything beyond it that we can't see would have compressed into a tiny infinite point we call the singularity. Actually, no. That would be true if the universe is finite, but if the universe is infinite, and it kind of looks like it is, then it was always infinite. So the Big Bang would have happened literally everywhere. This means that the first galaxies did not form in any particular region of space. They formed everywhere in the universe, even beyond the observable universe that we cannot see. It seems as if matter came into existence everywhere in the universe at a particular time, and the cosmic microwave background radiation that we see everywhere in the universe is the first light of matter coming from every direction in the universe. So, this suggests that the singularity is not the point from which everything came, but rather an infinite place where everything everywhere came into existence about 13.8 billion years ago. But wait, what I've said so far perfectly explains the mysterious nature of our universe. But new discoveries from the Webb Telescope are challenging the estimated age of our universe because each deep field image from the James Webb Telescope reveals unexpected things that force us to rethink the Big Bang model of the 13.8 billion-year-old universe. Ending the year 2022, it was believed that the most distant known unconfirmed galaxy was SBT 0311-58, but further studies showed that it was just a nearby galaxy that appeared to be highly redshifted due to dust clouds. But recently, the James Webb Telescope again discovered an ultra-high redshifted galaxy which shattered all our theories. Scientists just discovered GN Z11 is a candidate high redshift galaxy with an estimated redshift of approximately Z equals 20.4, corresponding to 168 million years after the Big Bang. If confirmed, it would be one of the earliest and most distant known galaxies observed. Well, this galaxy is still one of the most distant candidates and will have to undergo many tests to get confirmation. But if confirmed, the standard model would need to be revised again to obtain a better estimated age of the universe. Well, a few months ago, the Webb Telescope discovered early massive galaxies a few million years after the Big Bang. Their existence is simply impossible, according to our current standard model of the universe, to produce these galaxies so quickly you almost need all the gas in the universe to turn into stars at near 100% efficiency, and that is very hard, which is the scientific term for impossible. Our own galaxy, the Milky Way, took 13.6 billion years to form, but the Webb Telescope discovered galaxies like our Milky Way just a few million years after the Big Bang. This discovery could transform our understanding of how the earliest galaxies in the universe formed. In another discovery with the help of the James Webb Telescope, research group GA-NIFS has discovered something extraordinary in the early universe. This time they discovered two merging black holes 700 million years after the Big Bang. It's amazing that the Webb Telescope's powerful full infrared has shown us the early black hole collision. Scientists believe that frequent black hole merging may be a route for black hole growth in the early universe. All these discoveries indicate that the universe could be much older than previously thought, or may have had no beginning, that it has simply always existed. As we just find that our universe appears to be infinite in size, it's plausible that its age could also be infinite. What we perceive as the Big Bang may have been just a particular moment in the evolution of this always existing causal set, not a true beginning. However, there's more research needed. It remains uncertain whether this notion of an eternal universe without a beginning can align with our current scientific theories to effectively explain the intricate unfolding of events during the Big Bang. That's all for today. Share your thoughts in the comments about this ongoing crisis in cosmology.